In this video, we are going to discuss about fault models. To evaluate the effectiveness of a test approach and the concept of the good and bad circuit, we must relate these faults to the circuit model. That is, we derive a fault model. The most popular approach is called as stuck at fault model. So it is classified into stuck at 0 and stuck at 1. What is stuck at 0 means the circuit which is short circuit to the ground. What is stuck at 1 means it is short circuit to the VDD. So though the stuck at fault model doesn't cover the entire range of the faults, we go for the stuck at open and stuck at short faults, but it will complicate the test pattern generation pattern. So it is happy that we will go for the stuck at 1 and stuck at fault because it covers a large number of faults. So you have to understand the no single test model is completely foolproof, and therefore the combination of several testing methods is often required. So let us now discuss about the fault model for the combination circuits. For that one, we will go for the gates. Okay, first let us discuss about the gate, because the combination of the gate is something but the combination circuits. So let us consider a 2-input NOR gate which implement the Boolean function f of x1 comma x2 is equal to NOR x1 comma x2. So if there is a fault in this NOR gate, so instead of the above function, it will implement any one of the functions like f1 of x1 comma x2 is equal to 0. So it can go to 0, or f2 of x1 comma x2 is equal to x1, or it will go to f3 of x1 comma x2 is equal to x2, and f4 of x1 comma x2 is equal to 1. So these possibilities are given by f of f, that is a fault model in the NOR gate. So f of f is equal to f. So f is a gate with a normal function, and f1 f2 comma f3. Okay, so where f1 and f2 f3 are the fault model of the f of f in the gate, fault function of f of f fault model in the gate. So if any one of the fault function of this fault model is implemented by the gate, it means that the gate has an engineer faults. So in practice, we will use the constant fault model of f stuck at 0 and the stuck at type or of the particular importance. So if we consider that with stuck at 0 type of faults at the gate at the input and the output, and stuck at 1 type of fault at the gate at input and output. So first let us consider there is a in your NOR gate, the output is stuck at 0. Okay, so if the output is get stuck to 0 means whatever the input we will give, the output goes to 0. So out of this 4 model, that is you can see these are the fault model like the f1, f2, f3 and f4. So if the output is stuck to 0 means only f1 will get executed. So we can write at if there is a stuck at 0 type of fault at the output, we will realize the function f of 1 of x1 comma x2 is equal to 0 for the faulty gate. Next, if there is a stuck at 0 at the input. So if there is a stuck at 0 at the input means the input, one input is 0, other input is x1. Okay, so that is the case. You will get x1 only you will get, right? If x2 is stuck at to 0 means you will get the value called x1. So here you can till it is x1 bar. So x1 bar and x1 are same, okay, here. So I can write f2 of x1 comma x2 is equal to x1, okay. Or otherwise you can write it as x1 x2 x1 bar x2 bar, like that, okay. So you can have nearly instead of 4 faulty model, you can have to write 6 faulty models, okay. And if suppose x1 is stuck to 0, you will get the value called x2 at the output, right? So f of 3 you will get. So if if there is a stuck at 0 fault at the input, you will realize a faulty function, right, of f of 2 and f of 3. So similarly, for if there is a stuck at one type of fault at the output, you will realize the faulty function f4 of x1 comma x2, that is equal to 1, right? Because if the output is stuck at 1, you will get 1 at the output. Next, if there is a stuck at 1 fault at the input, um, if x1 is stuck to 1, anything plus 1 is 1, and if you invert that value, you will get 0, right? So you will realize a function f1 of x1 comma x2 is equal to 0. If suppose x2 is stuck to 1, here also you will get anything plus 1 is 1, and the inverse of that one is 0, okay. So you will realize only f1 of x1 comma x2 is equal to 0, faulty function at the by the faulty gates. So the engineering faults can occur with a varying frequency, which is defined by fault statistics. So what is the fault statistics of the gate? Here f of I represents the function of the fault gate, and P of f of I is nothing but the percentage of fault gate, that is equal to f of f divided by f of I. So f of I this is nothing but the function of fault model, right? So we have we can have 0, x1, x2 and 1, right? And you can have some alternative functions also. And if we substitute p of if we want to find the percentage of fault, p of f of 0, you have to write p of f of I is equal to f of f divide by f of 0, right? So if you want to find a x1, p of f of 1 here, right, that is equal to f of f divided by f of 1, okay. So so if I substitute the formula, I will get the equations like this. So if you see here, 50 plus 15 plus 15 plus 10, it is nothing but 90%. So the 90% of the faults are 90% of the possible faults are covered by this type of fault model, and only the 10% of fault is not covered, okay. So from this you can identify this is a better model, and so on basics of this fault model for the gates and flip-flop, fault model for the combination and sequential circuits can be obtained. So I hope this video is useful. Thank you.